We all know what a galaxy looks like, right? It's a huge collection of stars and other matter that's shaped like a spiral or an ellipse. And if you're an astronomy fan, you probably know that most of the mass is from invisible, mysterious material called dark matter. Well, NASA's Hubble Space Telescope just took an image of a galaxy that is none of those things. For the first time, astronomers have strong evidence for a galaxy not having a significant amount of dark matter. Most astronomers currently believe that dark matter plays a fundamental role in our universe and the formation of galaxies. This is because galaxies seem to have a lot more mass than what we can account for based on just the stars we see. How much mass is in a system is determined by measuring the speed at which galaxies rotate or individual stars in a galaxy move. Without the gravity from that mass, a galaxy would fly apart if everything in it is moving as quickly as we observe it moving. Decades of research have led astronomers to the extraordinary conclusion that 85% of the mass in our universe is invisible in all wavelengths of radiation, and that it's composed of matter that does not contain protons or neutrons or any type of particle we've detected before, and that this invisible material is all around us, passing through us without interacting with regular matter except by gravity. For some, that's a tough pill to swallow, and a minority of astronomers wonder if maybe we just don't completely understand how gravity works. If that were the case, and it was an inherent property of gravity that causes galaxies to move the way they do, then we could expect all galaxies to behave the same way. In other words, they would all seem to have about the same portion of dark matter. But with the galaxy in this Hubble image, astronomers looked at the velocities of 10 globular clusters in the galaxy, each a spherical collection of hundreds of thousands of stars, and calculated that their movements can be accounted for entirely by the mass of the visible material in this system. That means this galaxy has little to no dark matter. Strangely, this absence of dark matter actually provides evidence that dark matter is real. It shows that dark matter isn't always coupled with regular matter, that it's something separate. You can have regular matter without dark matter. This galaxy is really weird even beyond the dark matter thing. You may have noticed you can see straight through it. That's because this galaxy is what's called an ultra-diffuse galaxy, which, as the name implies, is extremely low density. This galaxy is about the same volume as our own Milky Way galaxy, but only has about 0.5% the amount of stars. Though astronomers have known about ultra-diffuse galaxies since the early 1980s, they can be difficult to find since they're so faint. A team of astronomers is using an array of telephoto lenses called Dragonfly to seek out these ghostly-looking objects. They obtained observations from Dragonfly, the Sloan Digital Sky Survey, the Gemini Observatory, and the Keck Observatory, then requested time on the Hubble Space Telescope to take a closer look at this unusual galaxy. Having images and data from multiple sources allowed the team to determine that this galaxy does not have a significant amount of dark matter. This was definitely surprising to find. No other galaxies so far have appeared to be so lacking in dark matter. In fact, other ultra-diffuse galaxies seem to have an overabundance of dark matter. The same team who studied this galaxy discovered a different ultra-diffuse galaxy in 2016 that they calculated was 99.9% dark matter. Yet another weird thing about this galaxy, the globular clusters used to measure the galaxy's rotation are way brighter than normal globular clusters. The researchers have written a different paper that focuses on just these oddball collections of stars. So this is a very strange galaxy in several ways. Astronomers will be looking at Hubble observations of other ultra-diffuse galaxies to see if there are any other examples of galaxies with unusually low or high amounts of dark matter. With more samples, astronomers will be able to better understand the nature of dark matter, the formation and evolution of galaxies, and the overall structure of our universe.